Thank you for the opportunity to speak about this long-running Bioschemas Training Profiles project. My name is Michelle Brazas, and I am presenting on behalf of my Bioschemas Training Profiles co-chairs, Layla and Patricia. So why bother developing a schema for training resources anyway? This audience knows that training is a critical component of research today, allowing researchers, students, and professionals to stay up to date with the latest techniques and technologies. While many of our institutions and training programs pump out an extraordinary amount of training courses and material, these are often fragmented and difficult to locate or harmonize because we lack a schema standard. From a findable, accessible, interoperable, and reusable or fair lens, this lack of standard creates a gap that hinders findability and by extension, accessibility, which in the field of bioinformatics training is a critical problem. This gap is exacerbated by our training silos. Specialized e-learning platforms like FutureLearn and Coursera exist, but they do not include training events outside their membership organizations. Institutional portals like EMBL EBI, Software Carpentry, Swiss Institute of Bioinformatics, bioinformatics.ca, and others only host training resources developed by their institutional members. Even wider efforts to collect training resources, such as Goblet's training portal, or to collect announcements of training events, such as the IN project or Elixir's training e-support system, TESS, have not fully taken off, mostly because training providers need to register or upload their resources, which is a step just too far and too time-consuming for many to complete. Training resources, though, are like any other scientific output, and as such, they should be fair. The goal of our Bioschemas Training Profiles project, then, was to create a schema that, when implemented, would help make training resources findable. The criteria for our schema work was that the schema needed to be in a structured data format, it needed to be readily implementable with minimal barriers. The schema needed to be able to facilitate aggregation of training resources, as well as the discovery of marked up training resources. A group of training providers, training networks, and related organizations covering a variety of roles, such as course developers, academic training providers, and training aggregator website owners, came together as a community beginning in 2015 to establish the schemas for training resources. And yes, I recognize that it's 2023 now, so this has been a long process. A series of meetings followed, including use case development and a crosswalk over existing terminologies. These meetings took place at Goblet AGMs in Lisbon and Toronto, as well as biohackathon events in Europe and bioinformatics education summit meetings. Over the course of these meetings, we refined the properties, assigned property marginality and cardinality, always testing against the use case for alignment. And in 2020, the chairship of the profiles passed from Teresa and Niall to Patricia, myself, and Layla to drive adoption and finalize the release of the schemas and publish an accompanying paper. And I'm happy to report here that we have reached the end of this process. Based on the use cases, the community discussed which schema profiles would need to be developed. Questions which arose during this process included: is online training considered a course or training material? What is the definition of a training course? Is online content considered a course the same as a 2-day workshop? What distinguishes a course offered once per year and a course offered 4 times per year? The training community came to a consensus on developing 3 training profiles, one for course instance, and training material. And I'll go over each of those in the next few slides. The course profile is used to represent any training course, workshop, conference tutorial, or e-learning resource. It includes properties to describe the content and attributes of a course, like its name, description, and learning outcomes. The properties in bold on this slide are the minimum properties required of the course schema. The course profile also includes properties that describe who is providing the course and the intended audience. The course instance profile represents a specific course offering scheduled at a given time or place. What distinguishes course instance from course is that a course instance is always associated with a course through the has course instance property. It cannot stand alone. The course teaches property, which describes the learning outcomes, is thus not a property of course instance. By linking course instance with course, one can mark up multiple offerings of the same course without duplicating the parent course metadata. This is useful for courses that are offered periodically or courses that are run in different locations. Another important feature of the course instance profile is that several course properties, specifically name and description, can be overridden by name and description in course instance to allow for variations in a given course offering. For example, a course named Intro to R may have a course instance that is specific for geologists and is thus named Intro to R for geologists. The parent Intro to R course would be superseded by Intro to R for geologists naming in the markup of course to course instance. The training material profile is used to mark up various learning resources such as books, videos, lectures, exercises, slide decks, etc. Training materials may stand alone or be linked to their relevant course or course instance. Continuing with the previous example, an R reference sheet may be developed as a training material and associated with both the parent Intro to R course as well as a course instance being offered in 2024. So I have presented some properties for each profile already, but in general, it took many iterations within the community to arrive at consensus on which properties would be used to describe which profile. The process was that we sat down and gathered all possible properties for a profile based on our use cases. Their prevalence across the community helped define their marginality. Properties were then refined by asking whether some properties were equivalent to each other, such as keywords and tags. The expected values for each property were then considered. For example, an author could be a person or an organization, and a version could be a number or text. Whether the expected value needed to be constrained by a custom vocabulary or an existing ontology, such as the standard for time, was also considered. Omissions were also evaluated. For example, did the course profile have all of the required properties, or were new properties needed? And finally, this description for each property was reviewed to ensure that a life scientist would be able to understand its usage. If not, then a new bioschemas description was written. To reduce the barrier to implementation, the community decided that a minimum of 3 to 6 properties would be required for implementing each training profile. This reduced the barrier to implementation. The properties selected to be part of the minimum required properties had to be essential to the discovery of a training resource. This process was aided, as previously mentioned, by evaluating how many community members actually use that property in their use case. As an example, every training provider uses the name of a course when describing their course. If a property was not essential, but still fairly important to facilitating the discovery of a specific training resource, then the property was listed as recommended. All remaining properties were listed as optional for implementation of the training profile. Consensus on the marginality of each property took a surprising amount of time. The biggest hurdle that we as a community faced was deciding whether the minimum set of properties should reflect our current usage or a future usage state that we should strive for. For example, should stating the language of a course be a minimum requirement or a recommended requirement? Most community members do not list language when considering their course, but maybe they should. So how did all these profiles and properties relate to each other? Here I am providing an overview of the 3 training profiles and their minimum properties for implementation, and which properties are used to interlink the profiles. As described previously, a course instance must always be associated with a course and cannot stand alone. Training materials, however, can stand alone or be associated with a course or a course instance. Most of our community is likely to use the course instance profile relationship or the training material profile. So how does one go about implementing these bioschemas training profiles within a web page? That largely depends on how your web page is managed. If you manage the web page yourself, then decide on which training profile or profiles you need to implement on a given page. Create the markup in JSON, microdata, or RDFA format. Be sure to include the standard requirements from bioschemas, as well as the profile's minimum properties. You can add any recommended or optional properties that are relevant to you. Then insert the profile descriptions into the HTML code for your web page, or ask your web developer to implement on your behalf. As an example of what the HTML markup will look like once implemented, let's look at an example. In this example of HTML here, you can see the blue is the standard requirements from bioschemas, the @content, @ID, @type, DCT conforms to, which define which bioschema's profile and release is being implemented. You can also see in purple the minimum properties for the course profile: description, keywords, and name. Once implemented, you will want to test that your implementation has been successful. There are a couple of options available for testing. The first and best option is available through schema.org. You simply enter the URL for your web page, and the validator highlights syntax errors for correction. Other validators are in development and are coming on board. Getting these training profiles released did encounter its challenges. As required by bioschemas, each profile needed 2 adopters before the draft profile could be released. Given that many training providers outsource their web development and management, schema implementation took a really long time. One challenge encountered by adopters was how to implement the schema on large amounts of historical data. Many adopters in our community were concerned about missing data in the minimal properties. The implementation of the schema, however, is current and forward-looking, such that minimum properties should be populated for all current and future courses and materials, and can have gaps in historical content. For other training providers who outsource their website development to external companies and are charged for feature implementation, updating their websites with a new schema was not a high priority given the financial cost to do so. As a result of these challenges, the adoption of each training profile has taken many years. but we have achieved success. Each of our training profiles has achieved at least 2 adopters, and so the profiles have moved from draft to release. Thank you to all of our adopters. We know the effort and hurdles you went through to implement these schemas, and thank you. If you have implemented one or more of the training profiles but didn't see your name on the previous slide, get your accomplishment out there. You can complete a form at bioschemas.org, providing the details of your deployment. Once the Bioschemas team has confirmed your deployment, they will post your name among the adopters for that profile. And finally, if you need more information, visit the training profiles on bioschemas.org or see our publication out this year in PLOS Computational Biology. And with that, I will end and see if there are any questions. Thank you.